going to jump right into it. We have a very interesting lineup today. I think it's going to be very impactful. So components for quantum, what we'll do is we'll give some updates on the quantum marketplace, and then we'll go over just a quick snapshot of how this is all, how we're seeing this in flow. We'll get into the lineup, and then we'll have a roundtable panel discussion and some upcoming events. So what is a quantum marketplace? It's a platform for raising brand awareness, facilitating collaboration, deals, and partnerships. We have both a web directory on QED-C's website. If you go to the quantum marketplace child page, you can see it there or the link below, and each of the companies that are offering commercial products or soon to be offering commercial products are indexed there. If they have a pink video icon next to their name, that means they've already also presented in the quantum marketplace. These are all recorded and they're later published and edited and put on YouTube via that link below. So some quick overview and trends. Today, we're going to have 6 companies present: Octave Photonics, Nexus Photonics, Modulight, Kyocera, and Hamamatsu in Vescent. Again, you can go to the quantum marketplace on YouTube and you can see this video and other videos from other quantum marketplace events. So in terms of, where do these companies fit? This by no means is an exhaustive, comprehensive list of where components fit, but just wanted to give an idea of sort of generalized areas of where the companies presenting today may fit. They may fit in multiple boxes, but this is where they fit. And then, fortunately, we were able also to have one of the companies that actually is a customer to potentially some of these. And so that's Vescent. And so in components, we're going to be covering PICs, detectors, laser diodes, and gain media, advanced optical and other materials. I won't cover so much advanced electronics from the component level. And then Vescent, they're a leading supplier of frequency combs, lasers, and controls, and they partner with various companies to bring that to the quantum ecosystem, which we see as quantum computing, quantum networking, quantum sensing, and quantum timing. Okay, so with that, the various presenters here, we have Zach, who's a co-founder of Octave. We have Seppo, who is the CEO of Modulight. We have Klea, who's an applications engineer from Hamamatsu. We have Tin, who's the CEO of Nexus. And we have Muzib, who is a principal strategist at Kyocera. And we have Scott Davis, the CEO of Vescent. And with that, Zach, can you share your slides?
Thanks, Mark, for inviting us to be part of the Quantum Marketplace series. My name's Zach Newman. I'm one of the co-founders of Octave Photonics. We're a small company located just outside Boulder, Colorado, and we're developing nonlinear and visible wavelength photonics like the chip shown on the right. Nonlinear optics is a large field, but in general, it involves the conversion of light from one wavelength to another using a suitable optical material. And typically, addressing optical nonlinearity is only possible when working at the very highest optical powers, but nanophotonic waveguides make it possible for nonlinear processes to occur at much lower powers because the light is confined in a waveguide that's only a few hundred nanometers across. As an example, on the top left is an image of a single ship with waveguides of different widths that generates different colors across the visible spectrum when pumped with an infrared laser. So quantum computers and optical atomic clocks, like the one shown on the top right, require dozens of visible wavelength lasers and optics, can take up an entire room and consume kilowatts of power. So nonlinear photonic chips, like the one shown on the bottom right, can help simplify next generation quantum sensors. But in order to get there, 2 key problems must be addressed. First, in comparison with silicon photonics for telecommunications, fabrication for quantum photonics is slow and costly, and that dramatically slows the pace of development. And second, fiber optic packaging and integration with electronics is critical. As an example, here's an image of a typical nonlinear photonics experiment where the photonic chip, which is highlighted in yellow, is surrounded by a myriad of free space and fiber optics that are required to get the light in and out of the chip. At Octave, we're developing easy-to-use devices based on our nanophotonic chips. For example, the module on the top left utilizes a nanophotonic waveguide to enable self-referencing of an erbium fiber frequency comb at 10 times lower powers and 10 times smaller volumes than is possible with conventional methods. On the right is an image of a broadband electro-optic frequency comb, where a waveguide is critical for spectral broadening. One of the things that makes Octave unique compared with other nonlinear photonics foundries is that we do full end-to-end product development. This starts with device design in simulation, followed by tape out and in-house fabrication with silicon nitride, tantalum pentoxide, and thin film lithium niobate. We test and package devices, and we've developed specialty packaging techniques for low-loss fiber chip coupling for visible wavelengths and high average powers. And finally, the team at Octave has an extensive background in nonlinear optics and quantum sensors, and we regularly assist with system integration and deployment. In fact, we recently installed one of our electro-optic frequency combs at the Keck Observatory on Mauna Kea. Going forward, we want to push on two main avenues towards making our nonlinear nanophotonics more accessible. First, we plan to build on our fiber chip packaging techniques, making the process more automated, allowing for scaling to large quantities. And we're actively working on both hybrid and heterogeneous integration to allow multiple devices and material platforms to work together in a single package device. And we're developing visible wavelength grading couplers using inverse design techniques to interface chips with free space quantum sensors. And second, we're currently working to establish a nonlinear photonics foundry that offers low volume, low cost chips and could fill a critical need for rapid prototyping to accelerate the design cycle for quantum nanophotonics. In plain English, you could design a waveguide device, order a single chip, and receive your chip within 3 weeks' time. Finally, we're continuing to develop new applications for nonlinear photonics, including microresonator-based devices for both broadband microcone generation and optical parametric oscillation. We're developing narrow line width SPS laser sources, entangled photon sources, and visible wavelength grading couplers and metasurface optics. Nonlinear photonics is in the early stages of development, so we're always looking to connect with partners, collaborators, and customers. So please reach out to us if you're interested in learning more about Octave, and thank you so much for listening. Here's some of our contact information.
Great, thanks, Zach. All right, Tim.
My name is Komljenovic. I'm the CEO of Nexus Photonics. We're very excited to be here. Thanks, Mark, for inviting us. So what is the problem that Nexus is addressing? We see a huge opportunity for integrated photonics in the emerging applications. Some of them are listed here. Obviously, quantum is the centerpiece of today's talk, but there are many others. And they differentiate from datacom and telecom markets in the requirements and the wavelength of operation. Typically, quantum is defined by the transition of the atom or other requirement. For AR, VR, we see a need to make PICs that are going to operate below 1 micron, mostly for sensing or for displays. Healthcare, it's same like quantum. It depends what you're sensing, and all others. And what they have in common is that operation actually should be pretty broadband, going from UV to infrared. If it's going to be a wearable, it has to be small and light. If it's going to be quantum, it has to be extremely high performance. Every photon counts. And if it's going to be battery operated, it needs to have high power efficiency. And so to enable that future and emerging applications, we are fully committed on developing and commercializing a fully integrated photonic platform with on-chip sources. Today, if you're doing things, as Zach has also shown, you're going to have a small, nice component, and then you have racks. We show images available online from Xanadu that's going to have racks and millions of dollars of equipment. And to scale the technology, we really have to leverage photonic integration. High performance components today come with high cost, and if you go with low cost solutions, they have poor performance. So solution is to develop a ground up photonics first broadband integrated platform. I'm going to talk a little bit more about the particular platform on the next slide, but I want to highlight the benefits that this type of integration brings to the end user. First is size. On the upper left, you can see a laser that you might recognize. It's a pretty nice laser, very expensive, very large, and very sensitive to vibration, shock, etc. Next to it, you see a Nexus equivalent, which in millimeter size gives you all the performance, roughly 2 orders of magnitude lower volume, and it's extremely robust, no mechanical parts, same level of performance. At the same time, we can reduce the cost. We can, of course, use legacy photonic packaging, but because we're using silicon as a substrate, we can actually leverage a lot of lower cost silicon photonic packaging or silicon chip packaging. And here you see a move from a traditional hermetic butterfly package to really ultra low cost. We're talking now cents to put a PIC that's going to work free space with your system. In terms of performance, we don't have time to cover. So if you're interested, feel free to reach out. But as a high level, we really offer state-of-art performance in a fully integrated platform. Our lasers work up to 185 degrees C. They have very high wall plug efficiency. In terms of line width, they're arguably the quietest sources, at least at this size, with line widths going below 100 hertz. And the platform is extremely broadband. A single active device as a laser can typically tune 10 terahertz, and then the whole platform can support more than 240 terahertz. And the last part on the lower right is the key point of having on-chip sources. So here you can see a wafer with a more than a laser PIC. So it has multiple functionality that's being automatically tested at wafer scale before simulation. And in this way, we can determine known good dies before packaging. This is crucial for scaling and also achieving high density. You can see the light because it's operating below the silicon band gap. So how does the platform look like? It's actually pretty flexible, but the main workhorse is silicon nitride waveguide with extremely low loss. Here you can see, maybe it's a bit hard to read, but losses are in the order of a dB per meter or lower, depending on the wavelength range. And then on top of these nitride waveguides, we integrate 3-5 materials in a heterogeneous wafer scale fashion to provide optical sources at a really broadband operation. Here you can see some examples of an indium phosphide 1550, gallium arsenide at 1 micron, gallium arsenide at 780, and early gallium nitride results as well. And it's not just the optical source. You can do all other components that you might be familiar with if you use traditional silicon photonics. So you can have waveguides, bands, splitters, crossings, filters, high Q resonators, etc. In terms of actives, you can have a whole set of lasers, amplifiers, photodetectors, and modulators. So how does it look? One thing is our laser is state of art, but it can go way beyond that. It can be a customer-specific photonic integrated circuit that embeds multiple functionalities and gives even more benefit of integration. On the upper left, you can see two examples. One is a laser that's split into two outputs. One is amplified, and you have monitor photodetectors to control the powers. So in this way, you can maybe suppress RIN or generate sideband. The second pic shows an example of two lasers coupled to the same waveguide. You could do like a blue and red shift to whatever you might be needing it for. On the lower left, you see automated testing on wafer scale again. Now the light is red. These are rubidium-based pics. And we fully qualified before singulation. In the center, it just shows you how we scan across resonances. These lasers can be very finely controlled, locked to the atomic species of interest. As a final point here, we would like to say we make things through commercial foundry supply chain, which gives you very high yield, very high uniformity, and very high functionality, and making pics that are more than a laser. On the lower right, you can see a screening example of a wafer. So this, to control the process, we scatter exactly 500 lasers and 500 PDs that monitor the lasers across the wafer. And here you can see screening results of a laser threshold and photodetector dark current. Extremely high uniformity and yield. So how to work with Nexus? So if you're interested in lasers and PICs, please reach out to us. We have a US-based, commercial foundry-based supply chain. Nexus can support the whole path from initial idea of your product and the design to fabrication with our foundry partners, to testing for known wafer good dies, to packaging and delivery to the end customer. We're running standard processes, but we can also do custom processes to meet your goals. We're a platform company. We design, develop, and deliver photonic integrated circuits. And our transformative technology really allows you, unprecedented performance, cost, and footprint improvements. So thank you for your attention. You have my contact details at the bottom of the slide. Thanks, Mark.
Yeah, great. Thanks, Tin. Seppo.
Okay. Thanks, Mark, for letting us present also at the Quantum Marketplace. And good morning, everyone. My name is Seppo. I'm coming from a company called Modulight. And we founded the company 20 years ago, and here is a short brief.
We do lasers and optics for personalized medicine and better life. Our headquarters are in Tampere, Finland, in the area referred as the Photonics Valley of Finland. All Modulight products are manufactured in Finland. We have expanded our production areas, and we now have 62,000 square feet of cleanroom and assembly spaces in the building. We grow and process our own semiconductor lasers, and thanks to this unique vertical integration, we can guarantee the supply and change control. We design and manufacture closely regulated lasers for medical applications, such as ophthalmology, oncology, and genetics. Cloud-connected devices process and analyze the big data from the treatment, which helps the doctors make well-informed decisions.
Yeah, and besides the life science, we sell the same lasers and the same technology to other high-value-add applications, such as quantum. The company has over 100 professionals, fully vertically integrated, over 20 years of investment and 50 million into the fab. I believe seeing is believing, so I invite all of you to touch base with us and see it first through the Zoom, but then more than welcome to visit us in Finland as well as in California. The overall, the company focuses to leverage the same technology. A few more glimpses from the company. So everything from epitaxy, characterization, all the way to mechanics required for the lasers can be built in-house. And obviously having the state-of-the-art tools allows us to fabricate some of the most demanding lasers. And quite a few customers actually told us that they view us having really the best laser fab in the world. Just in a nutshell, Modulight is offering to Quantum our ML66000 product platform. This is the same platform that we are using in our stringently controlled medical devices. It can be equipped with laser cores ranging from VCSELs to diode pumps things. We can manufacture DBRs using various grading technologies, etc. But I think perhaps most importantly, we feel that since the likes of Bausch + Lomb and several other big pharma are trusting Modulight, as well as some Fortune 500 quantum companies, we have over 20 years of history, as well as a culture of strong kind of support to our partners. And this makes us somewhat more, I would say, long-term partner. And if you are concerned about your supply chain and about longevity of your product, I believe we can offer a competitive alternative. We are working with the Fortune 500 customers, ranging from pivoting to R&D to production and end of life with our existing products. And as said, we have been happy to have a very highly equipped factory with technologies, basically all the conventional semiconductors, as well as VCSEL diode pumped sources and so forth. And what this means also is that you are sharing into the synergies created by the life science business. But if you want to learn more, please contact myself or one of my colleagues, and we'll be happy to talk more with you. Thank you very much.
Thanks so much, Seppo. Okay, Muzib.
Everyone, I am Muzib. I'm going to talk on behalf of Kyocera Corporation. Kyocera is a Japanese multinational with its headquarters in Kyoto, Japan. It was established in 1959 by Dr. Inamori. Today, it has worldwide presence and employs more than 81,000 people. You may know Kyocera from many different things that we do, but Kyocera in general has got very wide portfolio of products. We make components to devices to system to solutions. Today, I'm going to talk about a couple of our products that may be of interest to quantum computation industry as a whole. I will start talking about Kyocera Sapphire Wafer, ceramic packaging, photoelectric fusion solutions, and thermal conductivity solutions. And as you can understand that these are all very important for quantum industry. First one is Kyocera Sapphire. Sapphire is actually a single crystal alumina, which has got unique characteristics of high thermal conductivity, especially at a low temperature. Also, it has got extremely low dielectric loss, which makes it perfectly suitable for quantum qubit production. Kyocera has developed technology that enables us to make crystals which are low dislocation density, low impurity density, and low stress. We believe that our crystals will be a perfect match for all your needs. Next, I want to talk about Kyocera ceramic packaging. I'm sure all of you may have some way or other got familiar with Kyocera ceramic packaging. We offer many different kind of metallization and laminations, which allows various material properties to match with your perfect needs. High coefficient of thermal expansion to low coefficient of thermal expansion to high heat dissipation material with high robustness material, and so on and so forth. We also offer many different structures that will meet your needs. And the structures can cover from ultra small package of 1 millimeter by 0.8 millimeter dimension to very large size substrate of 300 millimeter dimension. We offer ceramics plus metal, where metals are attached to the ceramic for heat dissipation purposes. We also have got thin film metal on aluminum nitride and silver tin pre-solder. For Kyocera, we have got QPE packaging available as well. For superconducting qubits, we can offer flip chip or wire bonding solution on multi-layered ceramic PCBs. We can also offer wafer ceramic packaging. For photonic qubits, we can offer ceramic pin grid array or ceramic line grid array packages for all your needs. For trapped iron, we can offer aluminum nitride based packages with matching lead and anti-reflection coated windows with sapphire windows. So as you can see that we have solutions for all your needs, and I'm sure that our team of experts anywhere can help you. Kyocera also offers organic substrate solution. We have got 3 different types of solutions. One is flip chip ball grid array, and which comes in different formats, as you can see on the left side. And also FCCSP and modules come in a strip form that can be molded in the production. So today, what we want to talk about is what is the point that Kyocera is driving at. Kyocera, all of those things offer some value to the quantum community. Today, our quantum community, with so many bright people working, still we are struggling to make, a perfect quantum computer that are commercially available. So we understand that with the current error rate situation, we may need million qubits, but we also saw experts reporting that if we could improve the error rate, it could be, we could achieve the same goal within 10,000 qubits. And that's exactly what our goal is. We want to build products. We want to supply you with materials that can help you build products with a higher performance. And we hope that with our effort and yours, we can achieve that fault-tolerant quantum computation at a sooner time frame. Today, as I summarized before, we offer low defect wafer, KC2. These are very unique technology. We also offer high density multi-layer substrate for your QPU packaging. We offer high power laser diode that are still in development, but we welcome your input and inquiry. For the second generation and third generation products, we're looking at superconducting vias, as well as microwave resonator and ultra compact circulators. If you are interested in participating with us in this journey, please join us. For information, please contact me, Muzib Khan. I'm located in Silicon Valley in Sunnyvale. Here is my contact. Thank you.
Thank you, Muzib. Okay, Klea.
Hello, everyone. My name is Klea Dhimitri, and today I'm going to talk about how Hamamatsu fits in the quantum technology space. So if you're not familiar with Hamamatsu, we're a worldwide organization headquartered in Hamamatsu, Japan, and we've been making photonic solutions and components for around 70 years. And here is a breakdown of our sales by application. So really our bread and butter is medical instruments. So think PET machines, CT machines. Our second biggest market is industrial instruments. Think semiconductor, non-destructive testing. For about 10%, we have an analytical instruments. Think gas detection, methane detection, and water inspection. And then we have this others category that is comprised of smaller applications, as well as where our emerging technologies sit, such as LiDAR and quantum. And today we'll talk about our products and our place in the quantum technology space. In addition to providing components for industrial equipment, we've also been known to participate in very big scientific efforts. And I think this can be really well seen in high energy physics. We have delivered tens of thousands of detectors for experiments such as the Kamiokande experiment and CERN. And really what these efforts taught us is that building big and challenging ideas demand very high performance devices as well as reliable hardware. So it's always great to make a photonic device or solution, but it's very also important to make sure you maintain that precision and accuracy as you scale up to tens or thousands of them. And we think these are lessons that we can apply to the quantum technology space. In addition, I've just gotten some quotes here from members of higher management at Hamamatsu from a company report. And really the big takeaway here is they see a lot of potential and growth for us in this space. So let's just jump right in. So the first one area is quantum computers and simulation. And so you may have heard of qubit modalities like trapped ions, neutral atoms, and nitrogen vacancies. And they're typically racks of photonic hardware for light generation, beam steering, and detection and associated electronics. Now, of course, photonic qubits use photons, but they're a little bit different because they typically integrate a chip architecture. But again, the reason they have photonics in their toolbox is it's very important to apply things such as gate operations and detecting qubit states. So where does Hamamatsu play a role? Well, we really play a role in modulation and detection. So for modulators, we provide an LCOS SLM, and this is really great in confining atoms in a static array, and you can do this via optical tweezers, and you typically see this in neutral atoms. And for qubit state detection, we have a wide range of photonic solutions, detecting the fluorescence or lack thereof to tell you if your qubit is in a 0 or a 1. And some of our outlook for qubit state detection is we're working on trying to develop our SPAD arrays, as well as really work on some low latency readout for our cameras. And jumping into the next area of quantum communication and networking. So again, here the photon acts as a secure carrier of information, especially if you're going to transmit it over long distances. Similar to computers, you really typically have racks of photonic hardwares, at certain nodes or end users, and they typically include things such as single photon detectors. So again, we offer some single photon detectors in the NIR with different form factors, but future outlook for us is we're really trying to work on some high detection efficiency detectors in the telecom region. The last area I'll talk about is quantum metrology and sensing. Again, quantum sensors could be used to probe environments for very accurate measurements of electric fields, magnetic fields, gravitational fields, and timing. And so typically a quantum sensor will have some lasers, some optics, the qubit modality, and a detector. And again, when that quantum sensor is in that environment, that information of that measurement can be communicated through photonic emission, such as fluorescence. So again, we provide a wide range of photonic solutions, to detect that higher light level, as well as that single photon level. In addition, I was talking about some products that Hamamatsu makes, but we also have capabilities that we think could be useful for the Quantum 2.0 space, especially for products that we may not have right now. So we are experts in glass processing, semiconductor processing, really systems design. How do we combine that hardware, firmware, and software? And our laser promotion division typically integrates optics with some laser technology for products, in testing and equipment and manufacturing. And really our goal here is to provide key tools and equipment to help emerging quantum applications progress at every step of the way. And this includes both industry and academic research. And lastly, feel free to contact us, myself or my colleague, Taka Otake. And thank you very much.
Thanks, Klea. Okay, Scott.
Good morning, everyone, except for our friends in Europe. Good afternoon or evening to you folks. Thanks, everyone, for listening. I'm going to tell you a little bit about what we do at Vescent and how we fit into the value chain. Our mission is really enabling quantum commercialization. Let's grow the quantum economy, and that means getting quantum out of the lab. So the quantum potential, sort of why we're all here. Pick your big consulting firm. They all have reports on how big the economy of quantum is going to be. Here's a recent report from McKinsey saying it's going to be north of $100 billion. We divide this up into 4 different verticals: computing, networking, timing, and sensing. I'd like to point out that the Department of Commerce, the United States Department of Commerce, did a report a couple of years ago saying the economic impact of GPS, which is enabled by atomic clocks, i.e. quantum clocks, has already contributed greater than $1 trillion of economic activity just to the US. It's real. Quantum potential is real. The challenge, of course, as we're looking forward, is that it's constrained. Most of the quantum architectures and quantum systems require photonics. It requires photons to interact with the atoms or molecules that have to be very precisely controlled. And scalable and deployable solutions, they just don't exist right now. Most of it's being done with sort of R&D grade equipment. Well, this is where Vescent comes in. So we really break down the enabling building blocks into frequency combs, which is a specialized type of pulse laser, lasers, which is a CW, continuous wave laser for interrogating atoms and molecules, and then controls, which are a big piece of it. These are the electronics, the physics packages, the things you wrap around and make the photons do what they need to do. So a little bit about us. We're a quantum team that has both what I call reference level quantum expertise. One of my co-founders, he was a postdoc that built the original experiment for Eric Cornell that did the first atomic BEC. He made that famous plot in the upper left. Our CTO was Jan Hall's last graduate student who won the Nobel Prize for frequency combs. He worked on some early frequency comb work. So we understand how hard it is. We understand the physics. And then we also combine that with a commercialization and manufacturing track record. We are at our heart a manufacturing company. Now, quantum solutions are deployable. They can leave the lab. We know it because we're doing it. And so, we've got hardware that's in space, that's been deployed at sea, demonstrated in air. We don't have anything on an F-150 yet, but it's going there. It's hard, not going to lie to you, but we're ready. We're up to the challenge. And so we're seeing growing customer and partner pull. We sell to the researchers. That's where the big market is now. And so these are government players, FFRDCs, quantum labs. We have hundreds of customers. We sell all over the world. Quantum primes, these are the DoD primes. We sell and partner with most of them. And then, of course, the system level folks at the top. And so the folks who are building the quantum computers, the networks, the sensing, the timing. We're still a small company. We operate out of about 17,000 square feet in Colorado. We got a 3,000 square foot production clean room, but we're growing. And so a little bit more detail. The frequency combs, these are self-referenced. They can be atom tagged. We've got units that are operating 24/7 in fielded environments. Very proud of that. Our lasers, we have ultra narrow line with solutions, atom referenced, wavelength agile, and then our controls, things like ultra low noise, electronics, sub-shot noise, current drivers, offset phase locking, and then you wrap that all around advanced packaging to make it be deployable. And so for quantum enabling solutions, here's sort of a graphic I like to show. These things start in a laboratory environment on a big vibration stabilized table. There is Ted Hensch's first self-referenced frequency comb. We take that and we turn it into laboratory products that accelerate quantum R&D, and we sell those to the laboratory and R&D environment. And then we take it one step further into an OEM module that is for deployed quantum. And so when I say deployed, so here's an example of, here's our Gen 3 frequency comb. It's quite small, and we're beating the hell out of these things. We're putting them in through aggressive temperature regimes, aggressive shock and vibe regimes, and not just surviving, but operating and maintaining the required performance in that environment. And so I'm proud of that. And so this is what's going to be required for the quantum economy to realize its potential. We have similar things on CW lasers, not just the pulse lasers. So, there is Wolfgang Ketterle's lab at MIT for the first BEC. We now shrink that down, and we not only all the optics, but the electronics to make it simpler, to make the research simpler. And then you take all of it and you wrap it into a little gold box to get it in OEM deployed. And we've got customers that are doing cold atom systems that have been, again, shipped all over the world. And so it is happening. So in terms of the value chain, this echoes something that Mark had at the beginning. So the systems players are at the top, the people building the quantum computers, the atomic clocks, the quantum networks, the quantum sensors. Those are our customers. We manufacture the subsystems. I think of them as the building blocks, the combs, the lasers, controls that help enable these systems. And we are engineering these systems both for an R&D environment and a deployed environment. And of course, to make this system, we require components. And so we work with partners to buy things like PICs and detectors and laser diodes and gain media and advanced optical and other materials. And of course, advanced electronics. All these things are enabled to go into our subsystems that enable the quantum economy and for quantum to leave the lab. We're actively looking for key suppliers, partners, and customers to expand our solutions for Quantum 2.0. Here's our contact info. Don't hesitate to reach out to us. We like partnering with folks. It helps accelerate timelines. And that's it. Thanks, Mark.
Yeah, thanks, Scott. Okay, I'm going to start with Scott here. This is a long question, but I'm just sort of framing the background a bit, right? So Quantum 2.0 system solutions require, we hear this a lot, right? So throughout the ecosystem, leading edge hardware, sometimes really pushing the limits, right? And the subsystems and the components, you know, performance, reliability, ruggedness, given various operational environments, right? So how are you dealing with this? How are you addressing this early market build out with these challenges?
That's a great question. To be honest, we're sticking our neck out a little bit. You know, the market for deployed quantum is nascent, and so it's not that big, but we believe it is going to grow, and it's a bit of a chicken egg thing. So we're doing things like leveraging government programs. You know, the United States military is, of course, a market pull for this, and they've got some funding dollars behind them. It is, you know, when you develop a sort of industrial grade solution, you can sell that to the researchers too. They like it. And so you also have we have a research wing because that's where the business is now. And that's how we can keep our manufacturing line going. And that's, you know, exercising that production muscle. Yeah, it's a bit of a dance. So I don't know if that answered your question.
Yeah.
Adjacent markets matter too. You know, we sell to non-quantum customers that need quantum type things.
Right. So I want to go to Zach now. How are you looking at this, Zach?
Sorry, say it again, just at the...
Well, just, you know, so there's a lot of performance requirements with the various components and subsystems for quantum, right? So you need ultra low noise, you need a lot of reliability, you need ruggedness, you know, so when you're selling to these commercial customers, how are you addressing this based on, you know, this early market build out? It's not like it's a $10 billion market today. It's small, right? It's growing. But how are you addressing that? How are you approaching that as an Octave?
Yeah, I think we're just trying to, you know, meet the customer's needs as they come and not be overly aggressive in scaling up before the market's there. But you know, it seems like people are interested in visible wavelength laser systems, and it seems the demand seems to be growing. So we're just trying to do it as organically as possible. You know, as a very small company, that's sort of we have to be a little bit more patient, perhaps.
I think Zach hit on a good point, is that you have to have a structure that is right size, so that way you don't want to overbuild it and then have the market be, oh, you're only going to sell 10 of these or 100 of these or 1,000 of these. And so you have to figure out, you have to be realistic in your market projections, and then you have to right size the growth so that way you're economically viable.
Yeah, I think,
right.
Yeah, Scott, that's spot on. And thank you for rephrasing for me, because I think that was more eloquent than I could have.
I know what you mean, Zach.
Yes.
That's great.
We live it too.
All right, so thanks. So 10, what do you think about this?
Great question. You know, in terms of rugged performance, you know, we really see our platform as, you know, extremely unique. You know, these things can be launched from missiles. These things can be put at 4 Kelvin. These things can be put at 450 Kelvin. You can shock them, wipe them. There's basically no impact on the photonic performance. But of course, you know, you have to package it with the other stuff, which comes down to what others have said. You know, what makes us excited is why my first slide had a number of market verticals is, you know, we hope that quantum that needs, you know, really the best performance in the world can leverage a lot of other markets as well. And we see these synergies, and we really hope that the platform grows, leveraging multiple markets, you know, moving down to consumer space, which would give you volume, but using the state-of-art platform. So hopefully, you know, it's kind of a dance between the two as they grow. and quantum can leverage. But in terms of robustness, I really think photon integration is the right way to go.
Yeah, I mean, because versus classic photonics, right? So the promise of PICs, integrated photonics is huge, right? Especially what your company and Zach's company is working on, right? So it's fantastic. Seppo.
Yeah, thanks, Mark. For us, the recipe is pretty simple. We've been serving leading pharmaceuticals for 10 years. We always focused on building what the customers needed. It started with very early R&D. I guess some of the other people mentioned similar experiences that allowed us to create the company that was having solid growth for 10 years with high profits. We always invested all the profits to developing new technology, investing into the core technologies. Some of you saw in my videos, and I do believe, like my colleagues, that you have to have the right size. Now we have an extremely strong balance sheet due to the IPO, and we've been able to invest more, even if there has been a temporary hold with some of the customers. But I mean, I do believe in investing in the kind of fundamental technology and building product only for where the customers have a clear need.
Yeah, great. Thanks, Seppo. Muzib.
Well, this is interesting question. I think it's a chicken and egg. Everyone is talking about it, but we believe fundamentally where you start. We're talking about materials, talking about the quality of the materials that can really enable a super performing qubits, and then from qubits you create QPUs. So that's what we are focused on. We have the technology, we understand what it needs to be done, and we are always looking for partners who can share with us, can evaluate our products, and then take to the next step. So we are looking for everybody and anybody who is interested. Please come and join us, talk to us, and that's why my contact is over there, and my colleague, Mr. Tanaka, is also very interested and eager to participate with you. Also, I want to say that we have got worldwide presence, and we are very sure that our team of experts in each of these groups that I have talked about can help you, support you on a local basis. So that's how we are looking at it.
Yeah, and you had mentioned to me before that Kyocera, actually, you're touching on sort of various different divisions inside the company, right? So you have actually quite a few people that are paying attention to this inside Kyocera, and has a lot of visibility, right?
Exactly. So this quantum effort, it is a combined effort between multiple groups. And what we want to do is we want to really understand, what is requirement and how we can support them better. And each of these groups, that is what we are after.
Yep. Great, thanks.
Mark, can I make one more? I thought of one other thing that I think is relevant.
Sure.
So this is sort of along the lines of what Scott was also saying in terms of the chicken and egg problem, but at least for quantum systems, the market, the applications in the market are so new that no one's really certain about where it's going to end up. So, tailoring one particular solution maybe is a tricky task, because you have quantum computers that are all photonic, you have quantum computers that are, vacuum-based atom trap systems, and you have, maybe quantum computers aren't even going to be a thing, and it's all going to be discrete, small quantum sensors based on vapor cells, and it's hard to predict where all this is going. So possibly the most important thing is, like you were saying about developing material platforms, and maybe even more the relationships, like exactly what Quantum Marketplace is doing in terms of building relationships between all the companies that are sort of the providers, so that when the market becomes a little bit better defined, then we can all sort of start tailoring our solutions and cooperations to meet the needs of what the end user is, rather than like trying to figure out what it is a priori, and then that's
yeah,
gonna
I mean, there's
work itself out.
you know, there's multimodality approaches in almost every single quantum solution approach, right? And I think part of it is I just give you my own advisory on this, is I think part of this is certain things you can draw lines between that can fit multiple modalities. Other things a little bit more challenging, like you're saying. So, but partnering is a hugely important thing. But let me get to Klea. You want to wrap this up, Klea, on this?
Sure. Yeah. Yeah. So from a high level perspective, so one area we try to do, right? So we make the components. We try to find similarities, right? So telecom is not only hot for quantum. Actually, we started a lot of that development for non-automotive lidar, you know, space application, gas remote sensing. So we definitely try to utilize that. Second thing is I showed that high energy physics experiment. So the reason that worked is because they all agreed, right? So when you do these big efforts, you write a lot of papers and you say very specifically what you want, and you don't really move off of that, right? And so that was really easy for us, right? If you tell us specifically what you want and at the volume and when you want it, it's great. Now that doesn't really work for quantum. As Scott has echoed multiple times. So this is why we think places like QED-C is really important, right? Is trying to make those roadmaps as best we can, and really just start, you know, picking, prioritizing things, saying, no, I think this is more important. And then lastly, it is risky. And that's where we really think collaborations are important. And, you know, Japan has been part of some governmental collaborations. I think it's important, you know, when you get to really tough requirements, that you work with others so you can sort of minimize the risk. And, you know, let's say not lose too much of an investment. But, you know, similarly to the smaller startups in the larger company, Hamamatsu is not scared of hard problems. It's just, you know, you just want to be a bit strategic about it. So that's my thoughts on it.
Great. And I just want to, one more thing, just like Muzib, you know, with Kyocera, you know, Hamamatsu as well has quite a bit of support from upper management. It's a large company to continue to build out quantum, right? Lee? That was for you. Can you hear me? You can't hear. Can you go off mute for a second? Klea? Yeah. I just wanted to make the comment that it's great to see Hamamatsu have commitment as a large company in the space that, you know, coming up with solutions for quantum, just like Kyocera, right? We don't see a lot of big companies getting involved. We see a lot of big companies sitting on the sidelines. So you know, it's great to see that. Any comment on that?
Yeah. I think it's sort of a mixture. Yeah, I think, you know, we were very lucky in that a lot of the stuff used for quantum we had already built, right? Like PMTs and SPADs. But also the reason is that, you know, the way we've grown in the past is really by moving into new applications, right? We started off with PMTs, they were using high energy physics, and, you know, we eventually expanded that. And I think that's at the core of the Japanese spirit. You know, every time you hear these very nice management presentations, it's all about how we can improve society. And so, you know, we're not scared of risk, but, you know, I think you know, there is a strategic, and, you know, they can see potential and benefits as seen in these market reports. But I think there's also a motivation to even try it, even if we may not necessarily succeed, because, you know, they do see the benefit of quantum computers, quantum communication, and quantum sensing. So I think that's where the motivation is coming from, is that we think we can expand our capabilities and offer more, as well as, you know, we really think this is going to improve society. So I think it really lines up with Hamamatsu's heritage, typically in the past. So I think that's why there's a leaning to liking this space.
That's great. Yeah, thank you. Okay, so Scott, I'm going to go back to you with this one. So what are your, you know, quantum commercialization customers getting out of Vescent's solutions today?
Systems that work. And so you need a laser system that stays locked and doesn't lose lock for days and months and years. There aren't too many folks who can do that. And so, you know, we're helping solve hard problems. You know, the other thing is, because the market is nascent, is there aren't too many players in this space. And so we've made a strategic decision that this is going to grow. And so we're supporting the space and we're committing to it. And so that helps our customers grow, which then helps us grow. You know, another thing that I'll point out from your last question is the QED-C has done a lot of talk about quantum supply chain. This marketplace is the quantum supply chain. There's something nice about being in the supply chain side, because it's a bit of a hedge against architecture uncertainty. We don't know which modalities or even what systems are going to win, but we can look at sort of our product roadmap and say, no matter which one of these wins, 80% of them are going to need something that we're making. And so that's another thing that is beneficial about being in the supply chain side.
Yeah, totally agree on that. Let's go back to Zach.
Yeah. Yeah, I think the really big win for Photonics that I think all of our customers are getting from our products and solutions is the simplification, because the quantum systems are immensely complex, and the sort of proof of principle demonstrations are all pretty unwieldy lab experiments, and the photonic integration has the potential to make this much more user friendly, and that makes it accessible to a much bigger audience. So I think, yeah, for us, and I think also everybody would maybe agree that our main value add is that it's a simplification in the user and interface.
Mm-hmm. Thanks. Tim?
Great question. So I think things that make them most excited about Nexus is the performance we bring in, the density we enable, and then the ability to scale, both due to dropping down the cost of what they've been historically using, and also our ability to make it at scale. So, they're going to move from 1 to 5 to 100 to, millions. I think that's the only way to do. And, the performance is really exceptional for the form factor, and it removes a lot of other limitations. So I think that's why most of them are talking to us, but maybe you can also ask them.
Yeah. Okay, Seppo.
Yeah, we've been supplying photons or photonic generating devices now 20 years, very often as a sole source supplier. But what we also like to think of ourselves is that not only we supplied them yesterday, we're supplying them today, and we will be supplying them tomorrow. And I believe we're bringing to some degree, certainty and security to the supply chain, as well as offering a plethora of different technologies, so that our core mission is always to sell the customer what they need and not necessarily what they ask for the first time. And I believe our team has a quite wide knowledge of the different laser technologies. Thus, they can sometimes suggest customer to consider something that they didn't think at first. And this has been quite well received by many customers.
I see. Thank you, Seppo. Muzib.
It's an interesting, dynamics that's going on, I would say. If you had asked me a year and a half or 2 years ago, what's going on, I would not have been able to answer. But over the last 6 months, I have noticed significant shift. A lot of customers, a lot of OEMs are now curious to try our wafers. They are trying it, testing it, and packaging solutions, of different kind, and they're opening up our discussions with many of our groups. So this is a very interesting development. That means that there is a scaling effort going on, and they know that they need some reliable partners who can do a consistent quality products on every batch basis. Also, in the university level, we are seeing a lot of interest as well. They're interested to see how they can improve the current, from the current bottleneck to the next one. So we are getting inquiries, and we are having meetings almost on a daily basis in different groups within many different reputable universities, where the challenges that they are talking about and the challenges that we have identified are getting synchronized. So this is very positive. So what I want to share is, it seems like there is a momentum building going on, and eventually within the next couple of years, we will definitely see a lot of it, and it will be very obvious to others. But in this respect, I want to say that groups like QED-C definitely plays a huge role. The sharing of information, the platform that allows people to talk from different groups and different disciplines and different interests is really exciting. And similarly, I encourage you and Celia, to further enhance this activity so that it will be a lot more people will be visible to that and understand, what is the value that we can all create.
Thank you. Klea.
Sure. Yeah. So most of our customers use our products for prototypes, first for principle. And I would say what we really bring is certainty and experience. So when you build a new system, I'm sure there's going to be uncertainty, but it's kind of nice to know that your detector is always going to work the way you want it. And, if something goes wrong, it's something that we may have seen before. The next thing is experience. Quantum has these very tough requirements, like we talked about putting things in vacuum. Luckily, they're not the first people who have put things in vacuum. Now, we may not tell you if it'll always work, but we could tell you where things could break down based on past experience. So, when it comes to customizations, we can really bring experience and really try to have a collaboration of identifying a viable solution, saying, hey, we've seen that in the past, that may not work, maybe try this. And that's kind of really nice to just sort of slightly refine your system to something that could work for you. So I think that's the value we bring to the customers today with our solutions.
Great, thank you. So I want to go back to Scott here again. So what question are you hearing most from your Quantum 2.0 customers today?
I don't know that there's one. Standard, any customer, can I get it for cheaper? That's not unique to Quantum. People will ask us, can you, what's your scaling roadmap, and can you support us? And there's, when you're doing something new, there's always trepidation, which I understand. And so trying to convince folks that, yes, we have a plan. Yes, this is on our roadmap. Yes, we can do it. So basically confidence building, I think. The other, most of the customers today are the R&D customers. And so these are things like universities and government labs. And so they've got a certain way of thinking about things. The OEM customers, it's different. It's still pretty fragmented. I don't think there's any sort of, unique setup. I wish there were, but there's no, people are building quantum computers. They're still thinking they're going to be in an environmentally controlled room. And so their requirements are different. People who are building atomic clocks, they're going, I want to put this on a sub or on a satellite. Those requirements are very different, and then networking folks is sort of in between. And so, trying to figure out as a supplier, what's the sweet spot that's part of our challenge / opportunity.
Yeah. Okay, great. Tin, what do you think of this? What are you hearing?
Great question. So, the market is really fragmented. So, depending what someone is building, what are the atomic or ion species they're using, how does the system look like? Is it large? Is it small? So it really depends. But, there's always a laser. And, the laser performance is driven by whatever they're going to be locking the laser to. And, beyond that first talk, then the second talk is how do we increase density? How do we do more outputs, IOs, controls, manage noise, etc. So basically, it really comes down to what PIC could enable for them. And the good news is that we can cover a lot of wavelengths, and the performance is really stable across the board. But in general, I think it would help for the industry to select few choices and scale them up if possible. Just because, if everyone's using something different, then it's harder for them to get any kind of economy of scale. But that remains to be seen. As Scott said, we don't know which one's going to be deployed.
Yeah. I'm going to go back to Klea now. What are you hearing most today from your quantum customers?
So I agree with Scott's thought that it's sort of fragmented on the area. So if you look at computing, they care about scaling and fidelity, right? So they always care about trying to incorporate as much functionality as they can with a lot of engineering overhead. So what does that mean? Well, I want high QE detectors, but if you could keep it at room temperature, that'd be great, right? Or could your modulator hold more sites in a trap, right? So this gets a little tough, right? And then of course in networking, they really care about preserving that photon, right? So then that's going to translate to different things for the lasers and the detector. Again, a high quantum efficiency detector would be great. And then quantum sensors, the conversation's totally different. It's swap, right? So they may ask for high performance, but then that conversation is going to have to navigate to sacrifice. Like, listen, if you're really going to throw this up on a rocket or a ship, you really need to start thinking about not asking for that. So I agree with Scott. It really depends. And just based on those three areas, I think that's what each area cares about. And I think it bleeds into the components in different ways. It goes back to the system, right? How does the system scale? How does it, make sure it does the job? And how can I deploy it in all these different environments that it needs to be used?
Yep. Muzib.
All right. I will say it this way. we started our discussion, whether the packaging or wafer or something of that kind. And now we are seeing people are showing interest in evaluating them and seeing how they could be fitting into their solutions. But as I mentioned, the Kyocera has a wide, diversified portfolio. So we have got components, devices, products, and solutions. So as we talk more, the customers saying, "Oh, you can do that too? Can you help?" So I see more of questions as well as more openness to discussing things. So I understand there are different requirements and different challenges for each customers, but not all customers know all of our solutions. Not all customers are familiar with all of our products. So that is very exciting. Once we start discussing something, we hear a different story and different angles where we could help them. So this partnership, there is a growth in this partnership level, which is very encouraging. That shows that from a cottage industry, quantum is moving into a mainframe sometimes sooner.
Mm-hmm. Yeah. Seppo.
I would say reliability and predictability.
Yep.
10 years ago, we built remote diagnostics for gene sequencing company and have been ever since rolling that to many other high demand applications. And I hear a very positive response from many of the quantum companies that they at least have a diagnostic way to implement preventive maintenance, etc. This would be my 5 cents.
Okay, great. Thank you. Zach.
Yeah, I think I'd echo what Scott and Tin and Klea mentioned about we get requests for like customization like crazy. And I think our maybe
you have a short you're saying you're doing a lot and you have a short lead time. Of course you're gonna
yeah, that's right. That's inviting
that's sort of like self-inflicted, right,
yeah.
Zach?
I suppose we're inviting it on ourselves, but I guess I would say our task, like as a group, all of our companies in the QED-C and all the other member companies of the QED-C is to design, figure out like a standardization for all the quantum systems, like, sort of coming from a metrology background myself, that's been done to an amazing degree in telecommunications, and we need to do the same thing in quantum now, so that everybody has agreement on what they're working on and different wavelengths, etc.
Right.
Photonics is amazing because it's so flexible, and we have fortunately a very broad wavelength range that we can cover, but you can't cover everything. So having some agreement.
I mean, ask Tin, he's showing the whole damn spectrum, right? Almost, except for X-ray, right, Tin?
Well, Tin's the man, so
almost there.
Yeah, I mean, that's just wild, right? So anyway.
A double-edged sword, though.
Yes, it is. It absolutely is. Okay.
I also, just before you move on, I'll second what Seppo said. Reliability and repeatability and ease of use. When you're selling to a research community, 10,000 hour mean time to failure is maybe okay. When you're going to put something in space, it's not. And so we gotta up our game there.
And sort of, in my travels, what do I see is like, well, most of the ecosystem is selling into research.
Yep, right now.
And that's great. But for the commercial customers, they're like, I can't run this in a lab.
That's right.
Who's building it for me to go outside of the lab, right? That's the one I keep hearing from everybody. Going back to Scott again. So what is your company's biggest challenge, right, in succeeding in Quantum 2.0?
It gets back to my answer to the last one. Fragmentation is tough. And so how do you sort of pick your pool shots to make sure that you've got sort of enough breadth, so that way when things start to scale in volume, you've captured it, but you don't spread yourself too thin that you're not doing anything well enough. And so finding that right balance is always a bit of and it's, it's the wavelength challenge. The researchers, there are a million corner cases, and so you got to be careful to not chase sort of exciting scientific problems that don't have any sort of recurring revenue legs. And so, finding the right ones and finding the real, like, where is quantum really enabling? And then how are we going to provide into that? And what does enabling look like? What does the market look like? So it's a funny combination of sort of technical challenge and market challenge. They're both important.
Yeah. I'm gonna go to Klea now.
Yeah, sure. So, I think I echo kind of what Scott said. Currently it's quite easy, to give components that are needed, but components that are needed in the future are typically very different of what we have today. And so it's really trying to pick the R&D areas we should focus on, and then trying to make sure we can get at least some profit back, and when we invest in a production line or some R&D capabilities, and then of course it's the market uncertainty there as well. So I would say it's really R&D, and like I said, it's like when they ask for a spec, making sure have they really figured it out, if it's really going to double their performance, and really trying to prioritize. I think that's the biggest issue, and then of course trying to tie it back to our capabilities, right? Hamamatsu has certain capabilities that it already has, and then I think for us it's trying to figure out is that useful for someone, or does a customer know that could be useful for them? So it's a lot of exploring and collaborating, I think. But yeah, like everyone said, prioritizing really.
Yep. And then overspecmanship is a challenge, because you'll have customers that say they need things, and it's like, do you really need that? Because if we really hit this requirement, it's going to make this other thing incredibly hard, maybe make it not work. And so educating customers on sort of what those trade-offs are.
Yep. Muzib.
We see our challenges a little differently. We see our challenge is our inherent capability upgrade, which is from the research community.
Yeah.
That means from the university levels. Let's say we are looking for partnership where we could break through new barriers. We could come up with totally new innovation that we could leverage our own capability to develop into commercial product. That is one. Because we are an enabler. From the OEM communities, we are looking for their partnership in understanding of what their current needs are and how we can support them. Because these are the two different things that we are currently working on, and we have got our own roadmap of moving forward. Now, do we, like I heard from others, that it's a scattered industry, there are segmentation, their needs are different. I believe there are differences, but then there are commonality. And that's why we are very excited that we are in this space today, where we can see that in future, we can offer a lot more than what we have been able to do today, because we are learning more, we are organized more, we are now getting more focused, and we see the traction going on. So we are obviously very optimistic.
Yeah, great, thanks. Tin.
So I think it kind of mirrors what was already said, that balance of fragmentation and focus on commercialization, and being careful of what are the specs that you need for a product versus just showing the best result in the world. And I think there's a lot of progress. People have moved a lot in last years in the whole ecosystem. Good thing for Nexus, we are thinking about our platform as buckets. What is the 3.5 material on top of it? So multiple customers or even multiple markets can kind of grow it together. Yeah, I don't know. I'm feeling very optimistic these days, and definitely much more optimistic than before in engagement with customers, because specs are really clearly defined and they seem to be reachable from the PIC perspective. Coming to what's quantum systems going to work, that's problem beyond Nexus.
Right, Seppo.
Yeah, I see the pain shared by my colleagues. We made some big bets on a certain very focused wavelengths. Obviously, we don't know which one of them will succeed. I basically tried to piggyback a little bit on some of our life science technology to make sure that there is enough fuel behind the chosen paths. But we'll see where it gets. But that's my plan.
Okay, great, thanks, Zach.
Yeah, I think maybe for us as a super small company, one of our challenges is maybe making sure to diversify. A lot of our current customers are all very heavily quantum focused, and I think a lot of other people echoed this. Tin's making lasers for LiDAR and AR/VR and stuff, and I think one of our challenges is to find other applications for nonlinear optics outside of quantum, so that when quantum takes a long time to really mature and develop and find its place, that we don't go out of business in the meantime.
Yeah, the time to market
that's a
uncertainty
real
is
concern
real.
for us. That's a real concern for us. So for tiny companies, it's diversifying a little bit is important.
Right, and with that, thanks. With that, this next question is inspired from some of the audience chatting. Essentially, what I want to summarize here from multiple points is, is there adequate capital? And I'm going to start with Scott. Is there adequate capital for big firms? A lot of them are using internal, balance sheet money, and smaller or mid-sized firms, or even smaller firms, like you're saying, Zach, going for external funding. Is there enough capital so that you can succeed? What do you think?
So there's been a significant amount of both government and private capital going into quantum. The vast majority of it is going into the very top. And so it's going into the systems providers. And most of that's going into the computing side. And so, how many billions of dollars have been investing in quantum computing? Sometimes when I look at the whole ecosystem, I go, all right, you got billions of dollars going into quantum computing, and you flow that down through the supply chain. It's like, that whole thing falls apart if this one little 3-person company goes away. It's like, they need to pay attention to that. And so I don't think there's adequate capital going into the supply chain. And I think, so I would certainly advocate that there should be more focus on what is the foundation, what is all this built on, and what are your vulnerabilities? And, investors are sometimes a little bit like raccoons. They get excited at the shiny object, and a quantum computer that's going to disrupt the whole world is shiny. But it's like, well, what makes that possible? What makes that work? What are your vulnerabilities? And so I would encourage investment community to look at that.
Great, thanks.
Maybe a bit of a self-serving answer.
Well, it's all right. Seppo.
Yeah.
In terms of funding, you guys went publicly recently, but what do you think?
Yeah, we've been quite fortunate to, the company was founded more than 20 years ago, and we ran the company bootstrap mode for 21 years. So I guess you could say that we're not that savvy to funding. We were able to invest large amounts thanks to the old-fashioned business model that we run. We built a product, we built something, charge the customer, and then get some cash and invest that in the new technology and equipment. We've been quite fortunate with our customers being kind enough to pay good money for our product and service, and thus we've been able to invest. Now, more recently, I read from a local newspaper that the company has the strongest balance sheet of any company in Nasdaq Helsinki. So I think we're pretty good here, but there's definitely no denying that financial markets have gotten more difficult, and the climate is definitely cold in general for the VC, private equity, etc. So I could see that some of the companies, especially if they have a high burn rate, might find it tough. But I definitely intend to keep my own strong balance sheet and protect the company that way.
Yeah, I see. Tin, in terms of investment, right?
Yeah, it's a very complex question. I kind of Scott covered the key. There are definitely people that raised 500+ million, but they're doing end systems. And how does that transition to something deployed, which will need a lot of components, and moving away from $50,000 lasers or something. And Nexus is fortunate that we are pretty well supported by government to scale the quantum, while the revenue from commercial activities hopefully catches up. And what helps us, we are diversified, going for other markets as well. Yeah, I don't know. We haven't tried raising money for quantum, so I actually don't have comment there. We raised some money, but for a broader set of end goals.
And Zach?
Yeah, I think I have two thoughts on this. One is similar to what Scott said. Yeah, there's amazingly been a ton of investment from the government in quantum, photonics, all kinds of things like that. But it's true that a lot of the investment has gone to the large players. And, for example, the government has stood up, 12-inch photonics foundries, a handful of them with, hundreds of millions to billions of dollars worth of facility costs. And at the moment, it's not clear that exactly what role photonics plays in quantum. And even longer term, I'm not sure that anybody needs a 12-inch foundry. All these solutions are developing kind of on a custom one-off basis, and a 3 and 4-inch foundry might be more suitable. So there's been a lot of like big thinking investment in kind of huge scale systems that are stuck, but not as much investment in like the nimble, small scale, at least in photonics. And then the second thing is to investment. One challenge that we sort of see is that, the quantum computing companies that do total system integration, those companies have sort of see an opportunity for, like, if they get a big investment, they might grow by 10x or even 100x if quantum explodes. But maybe the OEM supplier companies like us, some of the smaller ones, we're more of a company built for long-term slow growth trajectory, and private investment may not be as interested in slow growth sustainable company as they are in a big return. So that's a challenge for us too.
The other point I'd like to make, Mark, sorry for jumping in, but the value proposition in quantum is different than in other markets, and certain things like telecom or consumer, things like PICs. It's not so much that you need to scale the cost down, it's that PICs enable lowering your swap, because as Zach said, you're confining your electric fields, and you just, there's no other way to do it. Or, things like environmental ruggedness. You put the whole thing on a little single chip and it's environmentally rugged, and you can temperature stabilize it. And so it's a bit of a different game. And so I think people need to be aware of the market dynamics.
Yeah, exactly. Muzib.
I will take a little bit break here, and I will say this way. Quantum is actually of strategic importance to our nation. So no matter what we say, fortunately, we are not in the space of, asking for money, and then 3 months later, we might not get it and we might go broke. And I think we should pose the question a little differently. For a strategic initiative like this, what are the things that need to be done and how we could do it? You talked about supply chain. Of course, supply chain visibility is important so that everybody can understand who are the players and how they can fit in. And it will be good for those companies too, to really understand, where they can match. And then they can pivot, or they could do something else. The second thing is the thing that we are talking about, which is the materials, the components. That takes a long lead time before you can really make it a commercial. And then there is a issue of not only the technology, but also standardization. So discussions among the supply chain and the OEMs and others is very, very critical, so that we could come to a consensus of what should be the standards. How do we progress to encourage the industry to grow further? The third one I want to say is, one gentleman talked about it in the Q&A, that what happened 50 years ago, if we look back, how we can scale quantum in next 20 years. I think we should look at that way, saying, okay, what are the things we should be thinking of doing so that in 20 years, it will be a full-grown, fault-tolerant, computer system that will be available everywhere. And if we can collectively make those kind of decisions and encourage, ecosystem to develop, I think we all will be gainer. We all will be very happy and successful. And there is no two way about it, because this is why I think the discussion should be, can this company sustain or not? Yeah, that is the important discussion, but is it relevant? If the company is relevant to the ecosystem, then we must try to make that company successful, because that's it. Once gone, there is no other one who will come and replace it. And from Kyocera's perspective, that's why I say that many times I say this, that as we are getting more exposure and our customers are getting more exposed to our capabilities, we are seeing a lot more reckoning and a lot more, interaction going on. I hope it will continue. I really hope that this will really flourish, across the boundary, not only in US, but across the world.
Yep, agreed. Klea, you want to wrap it up?
Sure. Yeah. So my perspective is a little different. Hamamatsu is just a little bit bigger than a lot of these other guys here, but we care about this.
Kyocera's on the line.
Oh, that's right. That's right. Sorry. But it's sort of the same thing, right? It goes back to challenges, priorities, and timeline, right? It's like, really, what do you really? I mean, what I hear a lot for quantum customers are really stringent requirements, but what they fail to say is when do they really need it? And I think some of the, being part of Hamamatsu, I've really appreciated what it really takes to bring a product from a prototype to an actual production line. There's a lot that goes into it. It's isolating manpower to do that. It's getting up that production line and getting test equipment. So I think some of these system suppliers need to be, maybe a little honest of like, no, I'll actually sacrifice this. And I really care about this because this is going to double my performance, in 5 years. And then, 10 years, we can work on that. I actually think everyone would benefit from that, like from startups to larger companies like Hamamatsu. But like we all said, for startups, they have to get the funding. For Hamamatsu, if we want to build a new building, we have to talk to our investors, right? So we really need to make sure that market is there. So I really think like what I hope to see in the next 5 years is just some real prioritization. And no one's asking it to be 100% sure, but can we say this is maybe the most viable thing we see here, and then we pivot, right? But having that transparency, I think, will help, because when it's a little uncertain or when the waters are murky, it's really tough for people to act, from what I've seen. So, any honesty and transparency we can bring to it, I think can really help us overcome a lot of these engineering challenges for all types of players.
Yeah, great. Thank you. Okay, so that's the event. Hang on for everyone. Just want to talk on October 5th, we're looking to do another one of these on metrology and control for quantum, so stay tuned on that. With that, Celia, do you want to make any remarks?
Well, I barely have a voice today, so I'll keep it really brief. But and apologies for being a little late joining. I'm going to go back and listen to the front end because this was a fantastic panel. I think it really highlighted the importance of all of the surrounding ecosystem that's going to be critical. You all did a great job of communicating, I think, how important it is to look at the big picture. I was just on a call earlier today with some folks that are friends in the Department of Commerce who were asking about supply chains and asking about what it's going to take to see this field move forward successfully. So I think that the message is getting out, and I really look forward to working with all of you at QED-C and helping you to succeed going forward. So thank you, Mark, for your outstanding job hosting this excellent panel today.
Thanks.